Webley-Fosbery Automatic Revolver, officially the Webley-Fosbery Self-Cocking Automatic Revolver. This Birmingham product married Lieutenant Tha's Colonel George Fosbery's 1890s patent to Webley and Scott's early 1900s manufacturing. Commercial sales began in 1901 and ran to 1924 in small quantities, chiefly a 6-shot .455 and an 8-shot .38 ACP version, each recognizable by zigzag cylinder cam grooves. It was presented as a gentleman's sidearm for officers and competitive shooters at a moment when semi-automatic pistols were just beginning to challenge service revolvers. Rather than a hand-rotated cylinder, the upper assembly recoiled on rails. That rearward travel cocked the hammer and advanced the cylinder via a stud riding the zigzag tracks, yielding a light, consistent trigger because the trigger's only task was to release the sear. A frame safety unusual on a revolver reflected the attempt to merge pistol conventions with revolver familiarity. In tidy conditions, it shot like a tuned match gun. Precision machining and close fits also proved its weakness. Mud, grit, and weak grip tension could interrupt the sliding top end or stall rotation. The guns were well finished and handsomely made. Yet the same tolerances that produce smooth cycling at Bisley were less forgiving in the field. Reports from colonial and early Great War users noted stoppages that ordinary Webley service revolvers shrugged off. Because it was expensive and delicate in service, then overshadowed by robust semi-automatic pistols and simpler service revolvers, the Webley-Fosbery never built a broad user base. Ammunition impulse mattered. Loads that were too soft wouldn't cycle. And .38 ACP availability lagged outside Britain. Survival today is measured in only a few thousand pieces, with short barrels and .38 ACP examples especially scarce. Collectors value them as mechanical curiosities more than duty arms. Stoner 63 Cadillac gauges. Stoner 63 of the 1960s pursued a single receiver that could become a rifle, carbine, automatic rifle, or belt-fed machine gun by swapping modules. Designers Eugene Stoner, L. James Sullivan, and Robert Fremont pushed modularity as a logistics advantage. Common training, common spares, roll flexibility. An improved Stoner 63A followed early trials, and limited operational use by SEALs and evaluators kept the concept alive into the Vietnam era. Internally, it used a long-stroke gas piston with a rotating bolt. Closed bolt operation served the rifle and carbine. Open bolt operation cooled the automatic rifle and machine gun variants. The sheet metal receiver could be inverted to move ejection and feed points, and the belt-fed guns added quick change barrels and adjustable gas regulation. A distinctive buffer stack and a carrier anti-bounce feature addressed bolt dynamics, while the short commando barrel traded reliability margin for compactness. Testing revealed a narrow operating envelope. Low-pressure tracer loads caused cycling issues, and heavy heat drove the cyclic rate upward into malfunction territory, including belt link separations. The later XM25 effort added a stock rate regulator, better gas sealing, tuned buffering, and strengthened polymer furniture. Those fixes improved behavior but arrived as U.S. drawdown removed adoption urgency. The commando configuration still lacked gas dwell length and remained temperamental, rather than becoming the rifle to MG family envisioned. The Stoner 63 remained an armorer's project, clever but maintenance-intensive, sensitive to ammunition port pressure, and awkwardly placed between emerging standards. Incompatibility with later common M27 links hurt long-term logistics. Production stayed in the low thousands and many were destroyed on retirement, leaving the design to influence later lightweight belt feds and semi-auto tributes while never securing a standard issue role. Bren 10, Dornau's and Dixon's Bren 10 appeared in the early 1980s as a service-sized pistol built around the new 10mm auto cartridge. With conceptual input from Jeff Cooper, the pitch promised revolver-class punch with semi-automatic capacity and speed, aimed at law enforcement and serious shooters. The line encompassed full-size and compact models, presentation editions, and commemoratives. The pistol combined a Browning-type linkless tilting barrel with a DA/SA system and an ambidextrous frame safety capable of Condition 1 carry. Inspiration from the CZ75 showed in grip geometry and control layout. while the stainless frame and carbon steel slide reflected a premium construction approach. Adjustable sights and small built-in tools for field maintenance rounded out the package. The manufacturing reality proved uneven. Financial pressure and supplier problems produced inconsistent small-part metallurgy, and early shipments sometimes reached buyers without working magazines. Spare parts were scarce, and factory support was thin even during the brief production window. Early 10mm ammunition offered limited availability and varied performance, which complicated user experience on the range. The pistol failed to gain lasting market traction because a high-priced brand-new platform with a fresh cartridge and shaky logistics couldn't satisfy demand or sustain quality. Yet it cemented the 10mm's presence and pushed later developments, including the eventual 40S and W and a wave of large-frame 10mm pistols from other makers. Surviving originals, especially complete examples with factory magazines, draw interest as artifacts of a bold but short-lived attempt to redefine the duty pistol. AMT-44. The 44 Automag pistol came out of late 1960s work and entered production in 1971. Promising 44 Magnum performance from a semi-automatic platform for hunting and sporting use. Through the 1970s and 1980s, multiple companies cycled through the design trying to stabilize production. With a modern boutique revival decades later, its short recoil action used a rotary bolt with multiple front locking lugs, an architecture that looked more like a scaled rifle than a typical pistol. Interchangeable long barrels and a single-stack magazine complemented the proprietary 44 AMP cartridge, which was formed by cutting and reforming rifle brass into a rimless 44 suitable for box magazine feeding. The approach delivered impressive ballistics on paper and a distinctive silhouette on the bench. Stainless construction and extensive hand-fitting produced tight, polished guns that also demanded careful ammunition selection and lubrication. Owners reported feed stoppages, light strikes, and bolt component failures when tolerances stacked or ammunition pressure varied. Corporate ledgers showed a different problem. The pistol was costly to machine, and early prices sat below what it actually took to build. Commercial momentum never developed because the platform combined exotic ammunition, fragile parts ecosystems, and production economics that punished every unit shipped. Factory ammo sources were limited. Many shooters reloaded, and support fluctuated as companies came and went. Today, early Pasadena-marked guns and custom builds are particularly sought after. The concept influenced later large-frame semi-autos that pursued Magnum energy with more forgiving designs and supply chains. Walther WA2000. Walther's WA2000 entered the precision market between 1978 and 1988 as a semi-automatic bullpup intended for police sharpshooters facing counter-terror incidents. The company produced fewer than 200 rifles across 300 Winchester Magnum, 7.62 by 51 NATO, and 7.5 by 55 Swiss. The rifle was promoted as bridging bolt-action accuracy with faster semi-auto follow-ups in a compact package. The gas-operated action locked with a rotating bolt behind a heavy, free-floated barrel that was fluted, clamped, and isolated to manage harmonics. The trigger could be set very light, and the stock adjusted extensively. Magazines were single-stack and specific to caliber. The bore line aimed directly into the shoulder to curb muzzle movement, while optics mounted to a dedicated rail system. Irons were omitted entirely. Craftsmanship was exceptional and also stringent. Machining quality, barrel treatment, and fit favored bench-grade performance but required attentive maintenance. In field tests, the system's mass and sensitivity to fouling or ammunition variation drew criticism. Disassembly for deep cleaning was more involved than agencies preferred, and overall costs dwarfed competing options. Agencies largely passed because price, weight, and upkeep offset the accuracy advantage. The rifle therefore remained a limited-run precision instrument rather than an issued tool. Collectors now view it as one of the rarest post-war precision rifles from a major maker, with first-generation configurations especially prized. The engineering choices barrel-centric design, recoil alignment, and optic integration echo in later precision systems, even as most duty rifles stayed with simpler patterns. Colt Double Eagle. Colt introduced the Series 90 Double Eagle in 1989 as a double-action/single-action rework of the 1911 pattern, offering full-size commander and officer lengths in several chamberings, A later Mark II revision addressed early internal retention issues. The company positioned it for law enforcement and civilian buyers who favored DA/SA controls and decockers but still liked 1911 ergonomics. Mechanically, it retained a tilting barrel, short recoil system, and single-stack 1911 magazines. The frame housed a DA/SA module with a decocker and a firing pin safety akin to Series 80 practice. Early pistols relied on grip panels to retain springs and small levers. Removing or cracking the grips could disable the mechanism, and some users reported finger pinch at the top of the trigger shoe during use. Most examples were stainless, with machining quality consistent with Colt production of the period. The interaction between the new trigger group and 1911 geometry made detail stripping less straightforward than on single-action Colts. Accuracy and reliability were described as serviceable rather than exceptional. With Mark II, changes improving part security but not changing the market equation. The Double Eagle faded because it asked 1911 traditionalists to accept a different trigger system while offering lower capacity than contemporary DA/SA competitors, and it arrived after the category had matured. Pricing overlapped with rivals that were simpler to maintain and carried more rounds. Today, the model draws niche collector attention, particularly in uncommon calibers and Mark II layouts, and it endures as an example of how grafting new fire control ideas onto legacy frames can create as many problems as it solves. Heckler Koch G11. Heckler Koch, with Dynamit Nobel and Hensoldt, pursued the G11 from the late 1960s to 1990 to lift hit probability beyond 7.62mm battle rifles while shrinking ammunition bulk. After numerous prototypes, troop trials of K1 and refinements into K2 culminated in German certification just as geopolitical winds shifted. The rifle's ammunition 4.73 by 33 caseless was central to the concept rather than an afterthought. A vertically oriented rotating chamber accepted square propellant blocks from a top magazine, turned them into line with the bore, and fired. The mechanism floated mass so that a 3-round burst at roughly 2,000 rounds per minute left the muzzle before the shooter felt full recoil. Constraining dispersion. An integrated optic replaced irons, and polygonal rifling arrived during development. Initial nitrocellulose caseless blocks were heat-sensitive, and without brass to carry heat away, the system risked cook-off. High ignition temperature propellant developed with Dynamit. Nobel greatly improved margins but increased production complexity. Precision sealing surfaces and moving chambers demanded tight tolerances and periodic parts replacement to maintain performance, raising the maintenance burden compared to conventional rifles. The G11 reached technical maturity at the wrong moment. Non-standard ammunition complicated NATO logistics. Costs were high, and German reunification redirected procurement priorities. Instead of fielding G11, Germany moved to a lighter conventional 5.56mm rifle that became the G36. The rotary chamber. Caseless ammo ideas continued to inform later telescoped ammunition research and modern thinking on heat management, sealing, and integrated optics for general-issue rifles, even if the original package never became standard kit. XM25 OICW. The XM25 Objective Individual Combat Weapon attempted to combine a 5.56mm carbine with a 20 by 28mm programmable airburst launcher and a laser-equipped fire control optic. Alliant Tech Systems led the program with H and K building weapon components. The goal was to let a single soldier defeat defilade targets while retaining conventional carbine capability. Work ran through the late 1990s into 2004. The launcher sat above a short-barreled 5.56 module. The fire control unit measured range, computed a burst point, and programmed the grenade fuse, which counted rifling spins in flight to detonate at the set distance. The carbine used a conventional rotating bolt, gas-operated action, and STANAG magazines. The architecture promised rapid switching between roles without separate accessories. Testing showed the limits. The complete weapon exceeded weight and bulk targets. The 20mm grenade's effects were questioned at practical ranges, and the short carbine barrel-trimmed velocity relative to standard rifles. Integrating power, optics, and 2 operating systems in one chassis added cost and maintenance complexity. As requirements collided with practical soldier load and lethality, the effort divided. The kinetic energy role migrated to the XM8 family, and the airburst concept became the XM25. Those separate lines carried lessons forward. The original integrated vision did not. In effect, the program demonstrated that the technical coupling of two weapons into one frame created more penalties than benefits for the individual rifleman of that era. XM8 derived from the OICW's kinetic energy module. The XM8 proposed a modular family to replace the M4/M16 line, built on a G36-inspired short-stroke piston and polymer architecture. It promised carbine, PDW, automatic rifle, and designated marksman roles with an integrated electro-optic sight and a new PCAP accessory interface. Early prototypes appeared in 2003 with additional builds following for environmental and reliability trials. Mechanically, it used a rotating bolt and composite receivers, and early literature called for polygonal rifling. The system emphasized a cohesive package XM8 magazines rather than aluminum stanag as standard, and PCAP in place of military standard 1913, unless adapters were used. The approach sought lower lifecycle cost by issuing one integrated optic laser rather than multiple separate accessories. Results were mixed. Some handguards softened or deformed under sustained automatic fire before material changes, and early powered sights needed battery life improvement. Weight targets drifted upward as features accumulated. The non-standard magazine and interface choices complicated compatibility with existing inventory and training. Without broad funding for competitive fielding and facing pressure for an open competition, the XM8 paused and then stopped. A direct descendant, the 40mm M320 launcher, entered service and spread widely. Program takeaways centered on strict weight discipline from prototype to production and the practical value of backward-compatible interfaces. Without those, a technically sound carbine can lose its advantage before it ever reaches line units. XM25 CDTE system. The XM25 emerged as a dedicated semi-automatic 25 by 40mm airburst launcher with an advanced fire control system, intended to give squads a precise way to engage enemies behind cover. The concept moved from lab benches to Afghan patrols between 2010 and 2013, carrying a 5-round magazine and a bullpup. Gas-operated action paired to a laser-equipped optic. The sight measured distance, allowed small offsets to detonate slightly before or behind cover, and programmed the grenade's fuse via data transfer. The round then counted spin to determine its burst point. This arrangement let a grenadier set air bursts above walls or through apertures instead of relying on impact fuses, which opened new engagement options but also increased system complexity and carried a power and maintenance burden in the sight itself. Units reported quick resolution of certain ambushes, while other formations declined to carry the launcher because doing so meant giving up a carbine and accepting a heavier, more specialized load. A serious in-weapon malfunction paused deployments during improvement efforts. Funding cuts and contractual disputes followed, and the program ended in 2018. In the end, the launcher's mass, modest ammunition capacity, unique supply chain, and safety optics outweighed its benefits at squad scale, especially as programmable 40mm options matured on existing platforms. The work nonetheless accelerated airburst fuse development for legacy launchers and clarified that adding a specialized shoulder arm to small units requires more than a promising ballistic idea. It must also fit the daily carry and resupply realities of the people using it. Really appreciate you watching. Your time and support mean a lot. If you like this one, consider giving it a thumbs up and sharing it with other firearm enthusiasts who'd enjoy it too. Feel free to leave your ideas or topics you'd like to see next down in the comments.